Hello students, welcome to this video. Let's get started. The topic of our today's discussion is Introduction to the Nucleus. We know that the nucleus is the dense center part of an atom. It contains protons and neutrons and they are together called as nucleons. That means the protons and neutrons, they are together called as nucleons because they are present inside the nucleus. Most of an atom's mass is concentrated in the nucleus. This is an atom and this is the nucleus. Most of the mass is concentrated here inside the nucleus, and this is the empty space, and these are the orbits where electrons revolve around the nucleus. So we can see that most of an atom's mass is concentrated inside the nucleus. Now, how discovery of the nucleus happened, or how nucleus was discovered? So it was discovered by Ernst Rutherford in the year 1909 when he performed Rutherford's gold foil experiment with his students. So gold foil experiment demonstrated a dense positive core in the atoms. A dense positive core in the atoms. Why it is positive? Because protons are present inside the nucleus. And this model replaced the plum pudding model of the atom, which was given by J.J. Thomson. Now, structure of the nucleus. The nucleus contains protons and neutrons, which are bound together by strong nuclear forces. Protons are positively charged and neutrons have no charge. And electrons, they orbit the nucleus in electron clouds. This is according to the new quantum mechanics model, but Bohr's model stated that they revolve in specific orbits. Now, protons in the nucleus. Protons are positively charged particles inside the nucleus. The number of protons determine the element's atomic number. Protons contribute to the nucleus overall positive charge because neutrons are there and protons are there inside the nucleus, and protons are positively charged, so that is why they contribute to the nucleus overall positive charge. And who accounts for the overall negative charge? Electrons in an atom. Now, neutrons in the nucleus. Neutrons are neutral particles inside the nucleus. They add mass to the nucleus, but they do not affect the charge. Because neutrons are present inside the nucleus, so they account for the mass. But as they do not have any charge present, they do not have any charge, so they do not affect the charge of an atom. They are electrically neutral. Neutrons stabilize the nucleus by reducing repulsion among protons. Now, if I draw the enlarged view of nucleus, we say that it is overall positive because of the protons. But what neutrons are doing, they stabilize the nucleus. They help in stability of the nucleus by reducing the repulsion among protons. If there are so many protons, positive would repel. So neutrons, they reduce this repulsion. They reduce this repulsion among the protons and help in the stability, overall stability of the atom. Next, nuclear forces. Strong nuclear forces hold the protons and neutrons together inside the nucleus. These forces are stronger than the electromagnetic repulsion between the protons. These are the strongest, not the strongest, but they are stronger than electromagnetic repulsion, and they act over short distances. That is why they act within the nucleus, which is a very short distance. So they act over very short distances within the nucleus. Size and density of the nucleus. The nucleus is extremely small as compared to the overall size of the atom. This was given by Rutherford, that size of the nucleus is very small as compared to the size of the atom. its density is incredibly high because of the presence of protons and neutrons with mass concentrated in a tiny volume. Nucleus size ranges from 1 to 10 femtometers. What does femtometer mean? 1 femtometer, it is equal to 10 to the power minus 15 meters. So we can see here that the nucleus is very much small as compared to the size of the atom. Next we have is the stability of the nucleus. Stability of the nucleus. A stable nucleus has the right balance of protons and neutrons. So we know that the neutrons account for the stability of the atom by reducing the repulsion between the protons. So a stable nucleus has the right balance. That means they have the right balance means the number of protons and neutrons are appropriate in the nucleus. Too many or too few neutrons can make the nucleus unstable. That is why we require the right balance of protons and neutrons. Unstable nuclei undergo radioactive decay to achieve stability. This we will study later. What is radioactive decay? Now, isotopes and the nucleus. Isotopes are the atoms of an element, same element, which have same chemical properties, same number of protons, but different number of neutrons. For example, carbon 12 and carbon 14. Some isotopes are stable while others are radioactive. For example, carbon 12 is stable. That is why we consider C612. This is the atomic number and this is the mass number as the carbon atom, and we do not consider this. Why? Because it is radioactive. Now, what is actually radioactive decay? Unstable nuclei which do not have the right balance of protons and neutrons, they are called as unstable nuclei. They emit radiations in the form of alpha, beta and gamma particles. These are also subatomic particles. So unstable nuclei emit radiations in the form of alpha, beta and gamma particles. This process of emitting the radiation by unstable nuclei is called as radioactive decay. Why the unstable nuclei do this? Why? Because in order to achieve the stability, if they emit the radiations in the form of alpha, beta or gamma particles, they can achieve stability, and everybody needs stability, right? So radioactive decay is the emission of radiations in the form of alpha, beta and gamma particles. Applications of radioactivity include dating fossils and treating cancer. We know that we use radiations to treat cancer, and also fossil fuels, dating fossils. There also radioactivity is used to determine the age of that fossil, how old that fossil is. Applications of nuclear science. Understanding the nucleus has applications in energy, medicine and research. Nuclear reactions, power stars and atomic bombs. Knowledge of the nucleus is crucial in various scientific fields. Now, nuclear energy. There are two processes, nuclear fission and nuclear fusion. Fission means splitting. So, nuclear fission includes splitting a large nucleus into smaller nuclei. And this is an exothermic process. That means energy is released. Nuclear fusion. Fusion means combination or combining of small nuclei into large nucleus. Also releasing energy. That means this is also an exothermic process. Nuclear power plants. We know that the nuclear power plants are used to generate electricity, and there nuclear fission process occurs. That means nucleus splits down. A large nucleus splits down into smaller nuclei, releasing energy. Here in this case, electricity is generated. Now, nuclear medicine. Nuclear medicine uses radioactive isotopes for the diagnosis and treatment. For example, PET scans, radiation therapy for cancer. So here radioactive isotopes are used for the diagnosis as well as the treatments. It provides a non-invasive tool to study and treat the human body. Non-invasive means it is non-harmful. Non-harmful as in it does not require any inserting of the instrument and all. It is a non-invasive process. Now, challenges in the nuclear research. Research into nuclear energy and applications faces challenges. Issues include radioactive waste, which is very harmful, safety, and public perception. Advanced technologies aim to address these problems. Now, summary. The nucleus contains protons and neutrons bounded by strong nuclear forces. Stability depends on the balance of protons and neutrons. That is why the neutrons and protons should be present in adequate amount so that the atom can achieve the stability. Applications include nuclear energy, medicine, and scientific research. Challenges involve waste management. The waste should be managed, and safety concerns. So what all did we study in this lecture? First, we got to know about the discovery of the nucleus by Ernst Rutherford in the year 1909 through his gold foil experiment. Then we studied about the structure of the nucleus, that it contains protons and neutrons. Protons are positively charged, neutrons have no charge, and electrons orbit the nucleus. Then we studied about the nuclear forces, that they are strong nuclear forces which act over short distances. After that, we studied about the radius of the nucleus. It is very much smaller as compared to the size of the atom. After that, stability of the nucleus, that it requires the right balance of protons and neutrons. Isotopes, atoms of same element with different neutrons. Radioactive decay is the process of emission of radiation in the form of alpha, beta, and gamma particles by the unstable nuclei. It has various applications. Then we studied about nuclear fission and nuclear fusion process. After that, we studied about its applications and challenges. So I hope you got all these points. Thank you.